Hello everyone, welcome to Code Comica's YouTube channel. Today we will be discussing about the scanning the infrastructure as a code, and regularly people use Terraform or CloudFormation ARM with the Chekhov. So there is a problem statement. Currently, the technical chains had been using multiple clouds providers such as AWS and Azure and Google Cloud. We have Alibaba and we have the other cloud providers. We have a bunch of cloud providers are available in the market. So when DevOps step into picture, like if you are using public cloud to provision your infrastructure, and if you have a DevOps engineer who had been working on cloud, so what regularly DevOps and DevSecOps engineer do, they do write infrastructure as a code, and they run all the infrastructure in a couple of fingertips and with a single go. They don't need to go and interact with the UI of each cloud provider and doing the manual work. So they have simplified with the Terraform. So Terraform is an infrastructure as a tool, like, and they can write the Chekhov language, and they can define all the resources, what all resources they want to create, and they can provide which they can specify which provider is it is AWS or Azure or Google Cloud or Alibaba. So accordingly, with by interacting with the code itself, they can go and create the resources as per the desired values. So this is happening since long time, like you might have seen infrastructure. Usually, DevOps engineer or DevSecOps engineer doesn't go and interact with the UI. So simply, what they do configure entire infrastructure as a code. They write the Chekhov language into their Visual Studio Code or any IDE, and they do keep this entire infrastructure as a code into any source code management, and they run it on any CI/CD runners. So accordingly, they will replicate all the instances this or resources they want to, and it will create it onto the cloud provider. So this is the traditional way, like usually people go and create the resources as per their desired values. So, but why we need to scan infrastructure as a code with the like in our case, we are using Terraform. You can use a um, you know uh, ARM templates or cloud formation role. So you know as per the DevSecOps best practices we had been following in this series, we need to scan our infrastructure as a code, and we need to see what all best configuration we have been following, or are we exposed any sensitive information into our infrastructure as a code, or are we following the best practices which is declared by a cloud provider or a infrastructure as a tool which is Terraform. So are you following the best principles and practices that we have been while writing the infrastructure as code? So that's why we should require a tool to look into that and let us know, hey, you are not being following best practices, or there is a flaw, or there is a misconfiguration you need to rectify, or hey, you are following all the best practices, or you are good to go for applying your infrastructure through infrastructure as a code into any one of the cloud provider. So that's why, to keeping eye on our infrastructure as a code, I brought Checkov. So Checkov is provided by BridgeQ, and this is the company had been taking care about this tool. And since it is open source, you can go on it, you can utilize into your environment. So there are hundreds of tools are available in the market where you can scan your infrastructure as a code, Terraform, and you can find the misconfiguration and all. So let's deep dive into the Chekhov, and we can see how can install it. And we have the Terraform Goat, TerraGoat as a vulnerable GitHub repository. We'll clone it and we'll scan the TerraGoat with the Chekhov, and we'll see what all misconfiguration it is showing. And we'll end this lecture at the end. So stay tuned until this video. You'll get the information about how can you secure infrastructure with the Chekhov. So I'm going with the presentation. So let's see what is a Chekhov. So Chekhov is a static code analysis tool for infrastructure as a code and developed by BridgeQ, and now it is part of Palo Alto Networks. And it helps the developers or DevOps engineer or DevSecOps engineer ensure their cloud infrastructure configuration or secure or compliant and adhere to best practices, which means like, are you following the best practices or not as per the current market. And Chekhov supports a variety of infrastructure as net frameworks such as including Terraform, CloudFormation, Kubernetes, ARM templates, and serviceless frameworks in configuration. So as we've seen, like it do supports Terraform, and which is HashiCorp language, and CloudFormation is for AWS and Kubernetes, and ARM templates for Azure and other frameworks. So that's how it's a it's a famous tool in the current market, and it is open source. You can go and you can download it. So in the last videos, like we had seen, how can we secure the infrastructure from code side, but not from infrastructure as a I mean, how can I say that? Like infrastructure as a code that we are currently discussing. But in the last videos, we had been seeing like how can we secure our code, and how can we keep, or how can we find the vulnerabilities from static analysis and dynamic analysis, and we had seen image scanning, and we had seen the finding the best practices and misconfiguration of Kubernetes manifest file. So when it comes to CI/CD pipeline, those all things are separate, and this one is separate because infrastructure as a code, like you do write and single go, and you just click it, and it will create all your desired values as per the actual into your cloud provider. But the thing what we had been discussing is other side, that we had been keeping eye on our code, which more writing the logic of business, and or implementing the database logics, and in connecting your front end and back end with the databases. So in terms of DevSecOps principle, you need to sanitize your environment at each corner. That's why I brought the checkout, because being a DevOps or DevSecOps engineer, you not only create the CI/CD pipeline with a SAST, DAST, or any other image scanner or manifest scanner. So your responsibility to scan your infrastructure as a code that you write into your infrastructure, and keep it in your source code management. That's why that's how we can keep our infrastructure as more sanitized. So let's not delay. Let's discuss about this checkout tool and what all benefits we have, and how it is simplifying, and how what all things it is resolve the issues in the market. So let's see, why do we use checkout? So we have the security and compliances, and we can use the checkout the scanner infrastructure configuration to identify the potential security issues and ensure compliances with the security best practices. And infrastructure as a best practices, we can use it, and prevention of configuration draft. That's true, like while incorporating the checkout CSCD, so we need to prevent the configuration drafts. And custom policy support, so as we had been seeing different tools, so it is also work on custom policy supports, and as per your organization security standards. And you can integrate with the DevOps tools. We have a bunch of DevOps tools like Jenkins, or you can use Azure DevOps. You can use the GitLab. So we have other tools also available in the market. So this checkout can fit with all the CI/CD pipelines tools, so you can integrate with that. And what are advantages like using checkouts? So early detection of issues, which means like by using checkouts, you can identify the problems in earlier stage in the development cycle itself, and reducing cost effect, reducing to fix them later. Because like if you have not been following the checkout, and if you have not been following best practices, like since you are using AWS cloud, so they do charge as per your as per the usage. So if you have not been following the best practices, and you have been creating unnecessary resources, it's going to be cost for your organization or your own pocket. So that's why like you can use a checkout to reduce your cost effects, and you can fix them as earlier stage in your development. And automation, so it automates the review of infrastructure as configuration for security and compliances, saving time and minimizing human errors. Because like as a human being, you can write or some kind of misconfigurations, or you may not follow the standards of syntax. So that's why a tool where we should have a tool where it can go and scan all infrastructure by pulling all its database standards, and it can fix that issue, and keeping the logs on a CI/CD runner level. And it can suppose extensive built-in policies, and you can customize and extensibility, and it can easy to use, and we have a giant community support. So these all advantages of using Chekhov, and let's see how can we install Chekhov into our Ubuntu machine, and we can see how we can use Chekhov to scan our vulnerable application. In our case, we have the Terragoat. So Terragoat is the vulnerable Terraform infrastructure. It has so many vulnerabilities, so you can use this as for study purpose. You can scan this GitHub repository with a checkout, and you can see what all best practices it is showing, what all vulnerabilities it is showing, what are security flaws it is showing. So we will see step by step, and first we'll see into installation part, and we'll see into um, uh, verifying part of our Chekhov installation. Later, we will see how we can scan our Terragoat with the Chekhov, and we'll end the session. So let's go to the documentation that I have bring the steps to installation of our Chekhov. So there is a prerequirement, which is like you should have the Linux install, and you can use a Python. So not only Linux, you can use the Windows also. If you are using Windows, you can go with a different kind of command line. You can use it. So since I'm good with the Linux, so that's why I'm bringing this installation on Linux. So first, you need to have the Linux infrastructure has been provided, and Python should be installed on it on top of it. So first, I'm going to update my system. This is the updating system. I install pip, which is a Python packaging manager. So what I'm going to do, I'm going to open my Linux. So I'm going to clear the screen and all for any unnecessary. So first, I'm going to update my system. So upgradation has been completed. The second step is like, and I'm going to install Python 3 along with the pip 3. So my requirement all is already installed, so paper is already newest version. So my case, it is already installed. If in your case, if you have any install, it will get installed. Now you need to install the checkout by using a pip, which is a Python package manager. So just need to pass pip3 install checkout. So once you press this button or command, so what will happen, it will bring all the required packages and modules, and so it will show you checkout has been installed successfully at the end. So now it has installed successfully. Let me clear up my screen, and I'm going to enable my virtual environment. So since we have been using a Python, so it's good practice to enable the virtual env. So first I will do, since I think I have already enabled, but yeah, I will enable, but for showing off purpose, so I'm just running the same command again. So I'm just activating it. Since in my case it is already activated over here, you can see here, check out env. So before recording the session, I just have walk myself through it. So that's why, it already showing over here. So pip install checkout. Oh, I'm running the same command again. My bad. Sorry. So if the installation is done, you can verify it. Checkout hyphen version. So this is a command, you can use it for um, you know verifying whether the checkout has been installed or not. So let's wait for this to be installed. I think I did a mistake, so I ran the same command again. So let's wait to complete this operation. I don't want to disturb it in between. I don't want to get these broken packages into my system. It may cause some other issues in the future. That's why I think it is ended. Oh, come on, buddy. Yeah, so it has collected all the information which is needed. So now let's verify whether the Chekhov has installed or not by typing Chekhov hyphen version. So we are at 3.2.43. So this is the version that currently we are using, and let's clone this repository. So this is the vulnerable Terraform infrastructure, which is a TerraGoat. So what I will do, I will clone this repository. I'll I'll add this repository URL into this video description. You can go it and you can clone it in your local. So I'll show you what all things which is in my local. So I can see I have the checkout environment which we have used to create it, and later I don't have any other folders or directories in my local Terraform directory. So what I will do, I'll use a git clone to get the TerraGoat repository into my local from the GitHub. So it is getting cloning, which is downloading. Now, if you see, TerraGoat has been came into my local machine. So what I will do, I will go inside of Terragoat. So cd Terragoat is a command to go inside of it. So if I do ls, so we have the all the GitLab CI and package.json, and we have the Terraform. So if I go to these, so this is the Terraform directory. We have all the AWS, Azure, GCP, Oracle. So we have the multiple cloud providers. So we can go to EC2 instance, EC2.tf. So this is a basic Terraform HashiCorp language. And you can go ahead and you can create all the resources you want. Like here, they are creating AWS instance, and they're taking a Amazon machine image. They're specifying the VPC with the security group IDs, and they're using user data to install or update the system. So these all things they had been doing, and that specify a few git commit and later retrace and all. And again, they are using AWS EBS volumes, so attach it, and and they're taking the EBS snapshot. So they have multiple resources you can use it, like AWS VPC. So these all the things had been configured: subnets, route tables, and network interfaces and all. So if you are using infrastructure as a code, so it is mandatory to specify all those resources if you want to provide a healthy infrastructure into any cloud. So let's not delay. Let's use this repository, which is we have downloaded, which is Terragoat, and let's scan all the directory with the Chekhov. So for that, we have the command. So this is the command to scan all infrastructure, which is check-out-d and dot. So this is a dot specifying, like you can scan all your current directory and the root level, or else if you want to scan any specific directory, you can specify it over it. So in our case, if you want to scan only packages, you can specify it. If you want to scan only Terraform, you can specify it. In my case, I would like to scan entire directories. That's why I have specified checkout-d as a dot. So if I press enter, so what it will do, my checkout will go and scan all the Terraform, and it will show you all the misconfiguration and all. So for first time, it will take some time. So now you can see it is scanning all the infrastructure, scanning all the directory. And if you come up, yeah, it found few misconfiguration. If you see this, it has found some misconfiguration. It is giving recommendations also to ensure your infrastructure is not stay away from misconfiguration and security issues. Let me go all the way to top, so you can see here, ensure RDS cluster configured to copy tags to the snapshot. It is saying that, hey, you have used this code, so you should have to configure a copy of tag into the snapshot. So if you want to get more information, you can log in into this URL, or you can go into or open this URL. You'll get the more specific information about it. So since this database has been getting is Prisma is a cloud. So, and as I mentioned, Palo Alto is the acquire of this checkout, and you can get more information. So it is saying that this policy checking to ensure that AWS IDs, which is relation database cluster, is configured to copy tags to snapshot. So tags are important to AWS as they allow users to categorize AWS resource in different ways, such as by purpose, owner, and environment. So they are giving the description, and they are giving the fix build time, and you can follow this script and you can fix your misconfiguration. So that's the one. And if you go to second, ensure RDS cluster have the deletion protection enabled. So there has been this specifying that, hey, whatever script that you have used, like RDS cluster, so you should enable the delete protection enabled for your infrastructure. Since they have been using the AWS resources, that's why they have picked up the particular code from 81 to 94, and they are specifying like, hey, you should enable the delete protection. So even if you see this, like they're specifying the file, and they're specifying the Terraform AWS rds.tf. They're specifying the folder path and file path, and even they're specifying AWS, like which line, 81 to 95. And if you see this, like they're specifying AWS RDS cluster, and they're saying alpha app6 RDS cluster. So this is the cluster information they had been specifying. So this is how, guys, Chekhov is very advancing tool. It can specify which line by line, and what exactly the location of your file. And if you want to get more information, you can go and log in into, you can go and open this into your browser, and you can see the mode information about the particular misconfiguration. So it is a severity low, and and enable detection protection on AWS relation database service. Cluster instances can help to prevent the accidental deletions. So it is saying that if you have enabled the delete protection, if somebody from your team is a developer or anyone, so if they are trying to delete it by not even intentionally, so if they cannot delete because you have already specified a policy for that, like delete protection, it won't get deleted. So when delete production is enabled, you cannot delete the RDS cluster or instance using the AWS management console. That is the truth that we have discussed very recently. So if you have enabled the delete production, so you cannot delete RDS cluster. So the AWS CLI or the RDS API, this can help to, if you want to ensure the RDS resources are not deleted accidentally, either by yourself or someone else or access your AWS account. So this is the best practice, guys, like by specifying the delete production for your databases. And let's go to the next one. So RDS cluster has are encrypted using KMS, CMKS keys. So this is the best practice, guys. Like you need to encrypt your KMS keys and all. So let's go to this URL and we can see what exactly the description of it and what is the severity of that. So severity is informative. So this is the Chekhov IDs, which is CKV, like how you have the vulnerabilities like CVs and CVs, how it is have its own unique ID. Like the same way, you have a Chekhov has its own Chekhov IDs like CKV AWS 327. So the description of this, like this policy is verifying an AWS relation database service cluster is encrypted using key management service, which is KMS, and customer management keys, which is CMK. Without this type of encryption, the stored data is not protected against unwanted access of a potential security risk. So they're saying that, hey, you need to verify the Amazon, which is a relation database cluster. It should be encrypted using the key management service or custom management master keys. So if you have enabled it, so it cannot be um, you know it should be encrypted. If you without encryption has enabled, so whatever data you have stored is not protected, and if any potential activities has happened, it can be exposed to the outside of the world. So that's why it is necessary to encrypt your data by KMS keys. So this is how, guys, like Chekhov is advancing, and it is giving each line by line, like where what file and what path and what line to line and what parameter you need to specify. We have the bunch of like misconfiguration. So if you have integrated this Chekhov into your infrastructure of your CI/CD pipeline while you're running your Terraform script, so it will give amazing results, guys. Like because like being a DevOps or DevSecOps engineer, your main agenda to stay away from your security incidents or security breaches or misconfigurations and all. So that's why we can utilize these open source amazing tools, and you can contribute yourself if you want, or you can utilize them and zero cost. You can integrate into your pipelines. You can stay away from misconfigurations and all. So if you see, guys, like we have bunch of like we have lot more vulnerabilities or misconfigurations or so it has some passed also. The Chekhov has passed a few one, like it is saying, hey, these all configurations has been passed, and for resources, and you can go and check it out. So if you see that passed to 52 and failed to 3 and skipped to 0, so it is giving the it is giving the scan information also, what all passed and what all failed and all. So this is how, guys, you can integrate Chekhov into our CI/CD pipelines. You can bring the dynamic misconfiguration into our runner log level. You can export it as a file. Like what you can do, you can run the same command, and you can uh, export it as a terrago.txt as dynamically into your in your pipeline, or if you're using it, you can take it as log output.txt if you want. So you can you can use it for communicating your developer or whoever you want. So accordingly, what they can do, right, they can look into that, and they'll get to know if you're a Terraform developer or administrators, accordingly can take the actions, what all things you need to refactor into your code. So these all best practices to following into your infrastructure by following the DevSecOps principle. And stay tuned to this series. We'll get amazing videos in the future. And the next video, we will see what all best practices we can use for configuration management. And we can use a configuration, a bunch of tools that are used in configuration management and all. We'll see how can scan our configuration management, and we can how can stay away from security flaws from or security breaches. So thank you for watching, guys. Like as I mentioned, as I used to say, I will add this tool into the CCD pipeline. If you are using Terraform, so we can see how we can use this tool for DevSecOps principle and all. And we'll bring this entire tools, bunch of tools that we had been discussing into CCD pipeline. We'll see, and we'll enable this on CCD pipeline level. So until then, thanks for watching, and share this video to your friends or whoever wants to learn the security or DevSecOps. And like this video, subscribe to my channel, and thanks for watching. Bye bye.